The material that we're going to look at here today are going to continue with the quadrilaterals, and we're going to, or the parallelograms, and we're going to specifically talk about several special quadrilaterals or special parallelograms. Okay, so we're going to start with something called a rhombus. Okay, a rhombus is what students, like in elementary school, I think they call it a diamond, okay, but it's called a rhombus. And a rhombus just means it's a quadrilateral that has 4 equal sides. And when I define it, though, I'm going to define it as a parallelogram with 4 equal sides. And the reason for that is that by using that word parallelogram, that means that all of those properties we talked about last class are going to apply to a rhombus. Okay, so its opposite sides are equal, its opposite angles are equal, its diagonals bisect each other, its consecutive angles are supplementary. So everything that we talked about in the last class, because it's defined as a parallelogram, all of those properties are also true for a rhombus. Okay, and in addition to this, a rhombus, because it's a parallelogram, it does have the area formula base times height. Okay, but it also has another area formula specific to being a rhombus that is the following. Okay, it's 1/2 the product of its diagonals. Okay, now, this is based on it when you draw a rhombus where all of these are equal sides. And basically what you can do is if you connect one diagonal here, you form these 2 triangles, right? So this whole base is, we'll call it D1. That whole base is diagonal 1. If I call this second measure here D2, what that means is in this triangle, if we split this into 2 congruent triangles to form this rhombus, notice I can call this base and this height for that, and that height is half of my diagonal 2, right? So what we wind up having right here is the total area of this rhombus is going to be 2 triangles. Each triangle is 1/2 the base of D1 times the height, and we established this height was 1/2 D2. And so notice what happens. The 2 and this half cancel, and now you have D1 times D2 times 1/2. That gives you your second formula. Okay, so for a rhombus, you can calculate the area either by using base times height or by using 1/2 the product of their diagonals. Okay, and again, if in doubt, what you can do is you can kind of sketch out your triangles, and you can use, and you can just build it up as 2 overlapping triangles, okay, that you can combine. All right, so I want you to see if you can answer the 2 area questions here that they give you on this slide, please. So notice in this first example here, it's just like what we saw in parallelograms in general, right? We have a known base, we have a known corresponding height, and so our area is base times height, where our base is 22 and our height is 17. So we can either multiply that out, write it as a product, or we can calculate it, and we would get 374. Remember, these are areas. Areas are square units. Okay, so, oops, you don't actually need to put u squared, but the u squared just represents some unspecified unit squared to deal with the dimensions. Okay, now for this second figure, the second figure we don't have the base. Now, you guys have enough information where you could find the base. It would involve some trig ratios, but you don't have to do that because we have this other formula that's based on the fact that there are 2 isosceles triangles like this shaded one that are just added together to form this rhombus. And so really what we're doing is we're taking the area of that one triangle and we're cutting it or multiplying it by 2. And the way that you can do that is just the straightforward 1/2 the product of their diagonals. Notice they gave you the diagonals here. So if we just take 1/2 of 66 times 37, nice and easy calculation to get our answer. 1/2 times 66 times 37, and we get 1221 for that. Once again, doing this on its own problem where you know this formula and you have it is different than doing it in a test where you have a lot of different questions that are asking you to like kind of go through and figure out what is the right formula for this. And so that's part of why anytime I can, I'll derive the formulas so you can see this is why the 1/2 product of the diagonals works for a rhombus. All right, questions on those properties? All right, when you're dealing with a rhombus, there are some special properties that also exist that are specific to it being a rhombus. And the first is that when you are trying to determine what is enough to say that you're dealing with a rhombus, and one of the relationships that's enough to say that is if you have a parallelogram, it is a rhombus. Notice how rhombus is spelled with RH instead of just the RO, but you have a rhombus if and only if it has a diagonal that or its diagonals are perpendicular to each other. Now, because it's a parallelogram, the diagonals already are bisectors of each other. So really, I mean, even though this specifically says perpendicular, it really is going to mean that they're perpendicular bisectors because it's a rhombus. That is what you're looking for. And so if you have perpendicular bisectors, then you are dealing with a rhombus. The other relationship that's true just for a rhombus, in order to demonstrate that a parallelogram is in fact has 4 equal sides, so same conditions, right? So if and only if. Here, each diagonal bisects the opposite angles. All right, so the ways that you can determine whether a parallelogram is in fact a rhombus looks like the following. If these diagonals here aren't just bisectors of each other, but are also perpendicular. Okay, so do notice a rhombus here, when you draw in those diagonals, not only do you have those 2 isosceles triangles that you can calculate to form the area, you actually have 4 congruent right triangles. And again, that might help you remember that those diagonals are perpendicular bisectors because they're going to create 4 congruent right triangles that make up that rhombus. And then here, the other relationship is, remember, in any parallelogram, opposite angles are equal. The only time that the angles are cut in half or bisected by the diagonals is if it's a rhombus. So if both of these, so these 2 angles are equal to these 2 angles, and if these 2 angles being bisected are equal, then you have a rhombus. All right, so see if you can use those 2 properties to answer the 2 questions from this slide. So when it comes time to remember this on your own, okay, so let me kind of talk through the thing to remember. If you have this rhombus, like I've drawn below, and you draw in your 2 diagonals, and remember, we create these 4 congruent right triangles. So this right triangle here, I'm going to highlight it. This is the same as every other sort of quarter of this triangle. It's a right triangle, so this side and this side are equal. This angle we'll say is 1 tick mark. This angle we'll say is 2 tick marks. So think about the parts that are congruent. So if we go over to the triangle below and to the right of it, in this triangle right here, we already have 3 tick marks. That means this side is 2 tick marks. This angle is 1. This angle is 2. Now we move down below. We have 2 tick marks, so that means this side is 3. We have our right angle here for each of these. So this is 1 tick mark, 2 tick marks. This is 1 tick mark, 2 tick marks. Notice we now have all of these measurements, and we can see this angle is equal to this angle, which is equal to this angle, which is equal to this angle. and then the angles with the 1 tick marks are each equal. And so if you need to redraw that to see where these different pieces are, but that diagram right there exposes all of the properties that we're talking about in those two theorems. Okay, so if we look at up above here, we see this is a rhombus. So the first thing you know is that each of these sides is exactly the same length. X is 56, so X is that angle measure. Okay, and so when you are looking to see what is the measurement of this, well, we know that these angles are being bisected by the diagonals of a rhombus. So that means that angle 4 is 56, angle 5 is 56, this angle here is 56. We have right angles here. And so if we want to figure out this whole angle EDG, so this whole angle from here to here is 56 times 2, so that's 112 degrees, which means that this next consecutive angle down here is going to be its supplement, so 180 minus 112. So that's going to be 68, and each of those is being bisected. So if we divide 68 by 2, we get 34 and 34. And now we can answer our questions, right? So angle 1 is a 90-degree angle. Okay, the diagonals of a rhombus are perpendicular bisectors, so that's perpendicular. Angle 2 we see is 34, as is angle 3. That angle is being bisected, and the consecutive angles are supplementary. Angle 4 is 56. It's also that angle is being bisected, so this is equivalent to x, the given measure. And then finally, angle 5 is opposite that and being bisected, and so that's also going to be 56. You can also think of it as being an alternate interior angle, right? AIA of these parallel lines. And you can use those properties as well if you don't want to use sort of the four congruent right triangles. Right, the bottom problem here, the information that they give is that angle BEC, or again, that this, you're asking, what would make this parallelogram a rhombus? Well, if it's a rhombus, that means that this has to be a perpendicular bisector. Okay, and so angle BEC has to equal 90 degrees. And so there's our expression. We could just type that in as an equation. And if we do, we need to zoom out to find the answer. We see that it's 11. So that, to me, is the easiest way to approach this, given the option to use the Desmos calculator. But if you're not using that calculator, what we would look to do is just solve this equation as it is. So if we took 90 minus the 189, we get negative 99 equals negative 9x. Divide by negative 9, and we get positive 11 is equal to x. And that would be our solution here as well. All right, so those are the properties that you need to be familiar with regarding a rhombus. Okay? A rhombus is a parallelogram with 4 equal sides. All right, the second special quadrilateral or special parallelogram that we're going to look at is a rectangle. So a rhombus is a rectangle or a parallelogram with 4 equal sides. A rectangle is a parallelogram with 4 equal angles. Four congruent angles. And each of them is a right angle, right? You have a total sum of 360 for a quadrilateral. 360 divided by 4 equal is 90 degrees each. So they're all 90 degrees or right angles. The area formula for a rectangle is base times height. And it doesn't matter which base and height that you use, right? Any base has the same corresponding height. You're given a rectangle here. So just the sides of the rectangle are your base and your height. All right, so see if you can take that, which is probably already familiar to you, and find the areas. The figure on the bottom right is a composite figure, which means that it's made up of different types of shapes. And so use that information to just combine all the given areas and add them together to get the total. So this problem is also asking for perimeter. It should be intuitive that the perimeter is just the sum of all of those parts. You can either individually add the bases and the heights. You could add 2 bases plus 2 heights, or you can add 2 of the sum of base and height. So any of those 3 ways to express perimeter is fine. And so here, if you just plug in 25 plus 13 plus 25 plus 13 is probably going to be what most would do, but you can also say 25 plus 13 and then multiply that by 2. You get a total of 76. And then the area, you're just going to take the base times the height. And here your base is 25, your height is 13. And so you can enter that as a calculation, or 25 times 13, you get 325. And again, the perimeter is a one-dimensional measurement, so this would be, there's no units provided, so that would be just U. Area is a two-dimensional measurement, so it would be U squared. All right. This last problem, again, and this is one where you do need to take a little bit of time. It's multiple steps in the way that you combine these. So we have a triangle, we have a rectangle, and we have a parallelogram. So the triangle area is 1/2 base times height, and so we need to find what is our base and what is our height. So when you're looking at these, opposite sides of a parallelogram are equal, opposite sides of a rectangle are equal, so that means that this height, or this length right here, is the same as this length. So we have 1/2 times a base of 12, and then this height is given as 7. So there's the area of our triangle. And now when we look at our rectangle here, we have this height is still a 12. Or the base is still a 12, and this height is 3. So there's the calculation for our rectangle. And I'll label these so you can see. And then finally, our parallelogram is also base times height. We have this base of 12. And this height is this measure right here. Well, that measure, we know that the total length here is 15. We have 7 of it here. We have 3 of it here. So what's left for this part? 15 minus 7 minus 3 leaves 5. And so there's your measurements. And again, you can just plug these directly in. 1/2 of 12 times 7 plus 12 times 3 plus 12 times 5. Okay, or you can calculate 1/2 12 times 7 plus 12 times 3 plus 12 times 5. You get your total answer to be 138. These are square units. Once again, you don't have to label that. It's just me talking through what the units would wind up being. All right, so just like with the rhombus, rectangle there are some specific properties that by themselves allow you to know that a parallelogram is in fact a rectangle, and the relationship is going to be that the diagonals are congruent. Okay, so if you have a parallelogram and the diagonals are congruent, then you're dealing with a rectangle. And so we'll word that in the following way. Parallelogram is a rectangle if and only if its diagonals are congruent. So remember, all the other properties of parallelogram also apply, right? A rectangle has equal opposite sides or equal, opposite angles are equal because they're all the same, 90. The diagonals bisect each other, but because it's specifically this relationship, not only do the diagonals bisect each other, but they are exactly the same. And each of these bisected segments here has the 1 tick mark to show that. Okay, all of those lengths from where the diagonals bisect each other are equal, because the diagonals not only bisect each other, but they're congruent as well. All right, so see if you can use those properties here to answer this last set of questions. All right, so if we take a look at these problems, the first thing I'm going to do is, again, I'm just going to go and list all the different things that I can about this figure up above, and then we'll go see what we need to find. If there's anything else that we need to, any other calculations, we can do that, but I do just want to sort of review all the different properties. So starting with this, we do have this rectangle here, and we're told that this RTS has an angle of 31 degrees. So we know a couple things here. The diagonals bisect each other. So what that means is that we have these two different isosceles triangles, right? So this is an isosceles triangle, meaning that this angle is also 31. Across from it is this congruent isosceles triangle. So those will each be 31 as well. Okay, these other right triangles that are, or these other isosceles triangles that are formed here and here, okay, these also have congruent angles, base angles, and those together form 90 degrees, so they are the complement to 31. So if you took 90 minus 31, you get 59 for that angle, which would also be here, also here, also here. And you also know a rectangle is a parallelogram, so opposite sides are still congruent. So if QS, or actually they don't have any of those measurements marked, but they do have QS, which is that diagonal, is a length of 12. So we also know that RT, the other diagonal, would be 12. And in fact, because these are being bisected, as it is in any parallelogram, each of these one tick marks represents a length of 6, if we need to know those measurements too. Okay, so now we could find other things. We could use law of sines and law of cosines here to find the missing sides QT and ST, but that you don't have to. Okay, but that would be like if you needed that information, we do have the skill set to do that. But let's answer our questions here. So QTR is 59 degrees. SRT is also 59 degrees. QRT is that 31 degrees. And then the length RT is 12, the whole diagonal. QP is half of a diagonal, so 6. And RP is also half of a different diagonal, but the diagonals are congruent, so it's also 6. Okay, and then this last question here, you have the rectangle. So you know that these diagonals are equal. So if we took these two measurements here, QS, which is 16x plus 11, set that equal to RT, which is given by the expression 14x plus 21. And so if we solve this, we get our x value. Now, notice it's not asking us for the x. Right? The sooner you kind of pick up, is it asking me to solve for x or evaluate an expression using x? I know I'm going to evaluate an expression using x. So before I even start writing my answer, it doesn't tell me which one I need to find, and I can do either one of them, right? They should both give me the same number. So I'm just going to take my expression 16x plus 11. I'm going to kind of enter that, and then this just reminds me, whatever I get for my x value, I'm going to plug in right there. So if I go into my calculator, 16x plus 11 equals 14x plus 21, and then find what is my x value. My x value is 5. So I can plug that right in here, and I get my solution, 16 times 5 plus 11. So that answer is 91. And let's confirm this. Let's make sure this is true. So if I plug 5 in for my other expression, 14 times 5 plus 21, do I get the exact same thing? Yeah. So this confirms it. I have a confidence level that what I've solved is correct. And not a bad idea to check answers if you get the chance. If I wanted to solve this by hand here, again, what I could do is I could move all my x's to one side, move my constants to the other. I would get 2x is equal to 10, divide by 2, and it confirms that x is equal to 5, exactly what I got when I used the calculator. All right, so what we have then is beyond what we've talked about with the just in general parallelograms, we have some special properties of a rhombus, right? A rhombus has 4 equal sides, and its diagonals are perpendicular bisectors of each other. We have the rectangle. The rectangle, or when you're dealing with a rectangle has 4 equal angles, all right angles, and the diagonals of a rectangle are congruent. Okay, so what if we took a figure that's both a rectangle and a rhombus? Okay, Okay, so that's what a square is. So when we're defining square, we are going to define it as a parallelogram. With 4 congruent sides, a rhombus, and 4 congruent angles, a rectangle. Okay, and so this is our definition here. So what that means is every single property of a parallelogram applies to a square, every single property of a rhombus applies to a square, every single property of a rectangle applies to a square. Okay, so all of those apply. So what that means is, regarding a square, the area formula could be base times height. Well, because the sides are the same, really this becomes just s squared, right? Where s is the side length. This is not a 5, this is an s. But a square is also still a rhombus. So with a square, you can, if you need to, use the area formula for a rhombus, which is 1/2 the product of the diagonals. Okay.
Thanks.
So keep that in mind. It saves you a little bit of time if you need to work with the diagonals. And you could use 45, 45, 90, special right triangle, okay? Because when you do draw in a diagonal on a square, you do create 2 of those isosceles right triangles, or 45, 45, 90 triangles. Okay, but you can also just use this formula 1/2 the product of the diagonals. All right, so see if you can answer these last 2 questions here regarding the squares. All right, looks like you were able to work through these pretty quickly. Right, so perimeter. The perimeter really is just the sum of all the sides. Since all the sides are the same length, you're looking at just 4 times the length of the side. And so here we have 8. The perimeter is going to be 4 times 8, or 32. Notice it's meters. It's a one-dimensional measurement. The area is s squared. And so if you took your length, side length 8 and squared it, which is 64, you get your area. Notice that's square meters. It's a 2-dimensional measurement. Okay, second problem, same idea here as with the rhombus and the rectangle problems. Let's just look at what we have. So we're told this is a square, so that means that all of these sides are the same length. We're told that LK is 16. That means that each of these would also be 16, right? Because you have a perpendicular bisector, and because it's a rectangle, or because it's a rhombus, because it's a rectangle, the diagonals are equal, so everything here will be 16. Now, if that is the case, so this is stuff that you don't necessarily need for this problem, but notice that each one of these individual triangles is an isosceles right triangle with legs of 16. So what would the hypotenuse be? What would be the length LM if you needed to know that? 16 root. Anybody remember the pattern? Root 2. And so if you needed to find what the total area of this was, and you wanted to use the calculation for a square, you could use the side 16 root 2. Okay, but here if we go in angle NLP, NLP is half of a 90-degree angle, so that's going to be 45. MKN is that right angle, so that's 90 degrees. KP is also the same length as every other half of the whole diagonal, which is given measure 16. And MP would be the whole diagonal length, which is 2 16s added together. Now, if I wanted the area of this, I could either take 1/2 the product of those diagonals, so 1/2 of 32 times 32, or I could have taken the area of a square, which is the side length, which we established was 16 root 2 quantity squared. So either of those is going to give us the area if we were calculating it. Now, this doesn't ask us to. I'm just showing you the different possibilities.